Hello guys, so we are back and what we'll be talking about, I have extended the database to two more companies 500325 and 500096. So what I'll be doing is I've downloaded data using this thing, using this function, and now what I'll be doing is I'll be making a color, running the whole process again so that yeah, I'll be running the whole process again, and I'll be running those in the order they are listed. All right. Okay, I'll run now Python simple.py. Next 10 is out of bounds. Which separation? Okay, so 0. All right, getting some exception here. Okay, I didn't actually download 500325, so I need to correctly download it. 500325. Maybe it's Reliance Industries. Yeah, no, I know. Okay, 500 00. Sorry for my low voice. I don't know why my voice is low. All right, so let's download the ratios. This company's ratios. I don't know. Then yeah. Let's see if we get the same error or not. 3.5. Apparently I need to export the Gecko driver. The Gecko driver is in my desktop, so Python simple. Okay. All right. Already have both of these, as you have seen. So we'll be downloading the ones which are not in our, yeah. It's taking a while. Okay, we didn't apparently download it. I don't know. Why didn't we download it? Let's see, check it again. Already have, yeah, both of these. We have both of these, yeah. So now we'll download this file. It's taking a long time, my darling. Okay, the browser already closed before we clicked the submit, like the download button. So this should not happen with this thing. Apparently, the script I've written is simple for a single stock, like running for a single stock, not for multiple stocks. I have to tweak it a little bit, so that it. All right. So we have actually downloaded all the data now. As we can see, we have all the data. 4 companies, as we can see, yeah, we have 4 companies. So now what we'll be doing is, yeah, code. Where's the code? Yeah. So we have all the 4 companies. Now what we'll be doing is training a model, and for that we'll be creating a new script, new file, simple 2.py. What we'll be doing is, yeah, I'll just copy paste something. Okay. I'll just copy paste the features we'll be using for our model. Alright, these are the features we'll be considering for the model. These are the features I have found that are not missing most of the times. And so the not available data is close to zero in this for these features. And these are the fundamental features. So what we'll be doing is building the data set first. Data df is equal to, let's import pandas. Import pandas as pd. pd.read csv. Read csv. all df.csv. We'll just shuffle the data using this code. Data df.reindex. Random or permutation. Data df dot index. So now what we'll be doing is, we'll be calculating the status in terms of numbers. So let's create a function first. Data def status calc. We'll be calculating the status again. So difference is equal to stock minus Sensex, then if difference is greater than, how much better? How much better will be defining that? One, else return 0. So how much better we will be defining that variable? Let's keep it at 10%. So now what we'll be doing is, let's create some white space here. So what we'll be doing is calculating the status 2. We have already calculated, but we are like, for the sake of automation, we are calculating it again. Price P change, Sensex P change, then we use NumPy to convert the features into values, NumPy array values. So we directly provide the model the NumPy values, port NumPy as NP. X is equal to np dot array and then we calculate the data df. We already have status 2 dot values dot to list. So we have the output. So we return x and y. So first, now what we'll be doing is calculating the accuracy of our model, and calculating the accuracy of a model. So what we'll be doing is we'll be using SVM for now. CLF is equal to SVM dot SVC kernel is equal to linear C is equal to 1.0 CLF dot fit. So we get XY is equal to build data set. CLF dot fit. Let's take the test size as something, a smaller number, 5. Then let's X CLF dot fit. Alrighty. So now let's for X in range test size plus 1. And we predict if CLF dot predict x minus x dot reshape zero is equal to y minus x. Then we have predicted it properly and we get correct count plus is equal to 1. So let's define correct count first. Correct count is equal to 0. So now what we'll be doing is printing this accuracy. Correct count divided by test size into 100. So the accuracy may like be very very volatile here because the training's data set is too small for us. So yeah, but if we enlarge it to a bigger training data set, it will be much simpler. And let's call analysis. We have used SVM here, so we need to import it. So let's import SVM from sklearn. I've just written the imports here. I'll just use them. These are the imports I'll be using. Many of them are not in use, but that's okay. I'll use them later. And valid syntax, okay. Okay, test size plus 1. I repeat, the accuracy will be very volatile. Okay, there's no price we change. How is that possible? How is that possible? Let's look at all the F again. How is that possible? Let's try again. Okay, they're getting. Let's look at all the F again. Okay, we need to pass two things. Need to pass two variables. Okay, this may work now, hopefully. str object is not callable. What the what do you mean? Okay, I've not added this comma here. This accuracy is 60%. Anything above 50 is usually a good sign that your model is somewhat working. And yeah, the accuracy is 40. Okay, the accuracy is very volatile here because we have small training data set. So what we'll be doing is so we can you can use this as a skeleton and increase the data set if you want, and I've shown it in the first few minutes of the video, how I increase the data set. And yeah, so